We had a request for some coverage of these examples out of the workbook, and so I thought I'd go through these and put them up in case you wanted to follow along. This question is about geometric series, and specifically it's about what happens if you have a geometric series with some steps missing. Can you fill in those missing steps? So an incredibly simple example of this would be if we told you there's a geometric series that goes 5, something, 20, can you figure out what would go in that gap? And for it to be geometric, we have to be multiplying by the same amount with every step. So we do 5 times something turns into this unknown number, times something again turns into 20. And without really explaining myself yet, I'm just going to say that the answer for this is 10, or the geometric mean is 10. Because if you put in that number, then we can say this is, start with 5, multiply by 2, we get 10, multiply by 2 again, we get 20. So that's the basic idea of finding a geometric mean. It's finding something to go in this blank that makes the string of numbers a geometric series, or geometric sequence, I should say. In this case, there's more than one blank. There are 4, and that's going to make this a little trickier, but we still have the tools to do this. So let's fight with this and see what we can do. They say they want 4 geometric means, and what that means, and so our sequence goes 81, something, 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 and then 1 over 729. Those 4 blanks are the geometric means that we're supposed to find. So when we've looked at geometric sequences, we know that you're starting with this number and you're multiplying by the same amount every time you advance by one step. And we usually call that amount r. So we multiply by r to get to there, and we multiply by r again, and we multiply by r again, and we multiply by r again, and we multiply one last time, and that gets us to 729. And really, that is all you need to set up an equation. What this shows us is if you start with 81, you then multiply it by r, 1, 2, 3, 4, 5 times, and that gets you to 729. So 81 times r to the 5th power equals 1 over 729. Well, that's not a beautiful equation, but it is something we can solve probably. If we want to isolate r, we divide both sides by 81. By 81, or here I'll go times 1 over 81 to keep the fraction from getting really uncivilized. So we get r to the 5th equals 729 times 81, 59,049. So we get 1/59,049th is r to the 5th, and if we want to know just r, we take the 5th root. Or you can think of this as putting it to the power of 1/5 if you'd rather. I think the roots read a little nicer. And from that we get r equals the 5th root. How do I do a 5th root on this calculator? Is 9, or I'm sorry, 1/9. The common ratio is 1/9. So you can think of it as multiplying by 1/9, or you could think of it as we're dividing by 9 every time you advance a step. The times 1/9 is probably better. When we're talking about sequences, we prefer to think of it as multiplying by an r every time, but in the privacy of your own thoughts, if you want to think of this as divided by 9, that will completely work. And now that we know that r, we can go back here and fill in all these gaps. 81 times 1/9 times 1/9 times 1/9 times 1/9. And if we go times 1/9 again, we do indeed get 1 over 729, so it worked. Those are the 4 geometric means between 81 and 729.